Hello everybody, Mr. Troy here. This is a video of Mr. Troy Explains Your Math Homework. Okay, so I'm going to look at these two problems from your homework, 76 and 77. They're some of the hardest problems from the homework. Your numbers are going to be different. For example, you might have 25 and 5, or 25 and negative 5 and 5, instead of 64 and negative 8 and 8. But you will have a perfect square and its square root and the opposite of that. Okay, so let's get started. Okay, I think the first thing that throws people off is that although this is the function listed, this function is not invertible. It doesn't pass the horizontal line test. Example. Boo! But there's more detail than that in the question. In the question, there is a domain given. So in Desmos, you can use this notation, curly brackets just like set notation, and then you can put an inequality in there to display just part of the graph. Okay? Now, if we think back to the most basic fundamentals, what we know is that the inverse has to reflect about the line y equals x, which means the inverse itself should show up here. As I mentioned in class, you can use this notation to actually display the inverse, but you're going to need to find it algebraically in order to type it in. Okay, now none of that was like a secret or anything because they did tell you the domain of the original function here and the domain of the inverse here. However, that's kind of easy to miss. You're not used to looking for a domain. We would call this an explicit domain. You're not used to looking at that. So, let's talk about how you would find the correct answer algebraically, even if you didn't know what the graph looked like. Although we've used that semicircle graph a whole bunch of times during this unit, so it should be a little bit more familiar. Okay, so here's why this is so fun. We've got the equation given to us. We'll write it in terms of y and x. Is y equals the square root of 64 minus x squared. We want to switch x and y, and then we want to solve. So we're going to start by squaring both sides. And then we can switch sides of x and y, and the signs of each of the things will change. So x squared will become negative and y squared will become positive, but the equation will actually still look the same. So y squared equals 64 minus x squared. This is looking a whole lot like our original problem, which is why a lot of people just enter the original equation as their answer, and they miss something here. So our next step is to take the square root of both sides. Now here's the thing that a lot of people forget. From Algebra 1, when you take the square root of both sides, you get y equals plus or minus the square root. Okay, so this is at the point where you're like, okay, I guess you showed me that it was above the axis here, so it'd have to be below the axis there, because we've got that line y equals x. But how would I know that algebraically? Well, and this is why this is one of the toughest problems, because you've got to tie all of this different stuff together. You were told in the original problem that this had a domain from -8 to 0. Now, if that's the domain of the original function, then its inverse has to have a range from -8 to 0, right? Because the domain and the range flip-flop, which means we're ignoring the positive part of this, and we're just taking y equals the opposite, the square root of 64 minus x squared. So if we plug that into Desmos, this is what our graph looks like. But then remember, we need to add the domain restriction, which is actually given in the problem. So the domain restriction for the answer is given in the problem right here. Again, this is how you would type that into Desmos, if Desmos is a tool you want to use. All right, let's move on to our next problem. Hey, I'm over here now. All right, consider the following function. This is an absolute value function, but we're only looking at it to the right of 7. Now, it helps to know from Algebra 1 what an absolute value function looks like. So here's that. So this is what an absolute value function looks like, but they're only asking you about this part of it. So the reason that we spend so much time during first semester, and we'll continue to spend so much time during first semester learning parent functions, is because it makes seeing this math so much easier. So if you think about it, if I wanted to reflect that line over the line y equals x, I probably want that, right? Instead of having the point 7, 0, it would have the point 0, 7. So that's how I'm trying to figure that out. Now, instead of having a domain restriction from 7 to 0, this would have a, or sorry, from 7 to infinity, this would have a range restriction that is greater than or equal to 7, which Desmos will actually allow you to type in. So for this problem, you have to know that you're talking about a ray, you know, half of the absolute value. If this is the absolute value, you're only talking about half of it. And the inverse function is going to be reflected over the line y equals x. So the inverse function is x plus 7. And then this is a key, the domain and range flip. So they told us the domain of the original one. They told us that the domain was greater than or equal to 7. And we have to figure out that y is greater than or equal to 0. Now, note, this problem asks you to use interval notation. I am typing this in inequality notation because I think that's easier for your brain to kind of figure out right away. You need to remember how to put that into interval notation. Now, the domain and range are going to flip. So the domain for the inverse is going to be x is greater than or equal to 0, and the range is going to be y is greater than or equal to 7. Again, this has to be in interval notation, so don't type this in, even if 7 is your number. Okay, I hope that was helpful. I thought that was fun, but, you know, I'm a math teacher. All right, everybody, hang in there. Have a good one. Talk to you later.